Hi, this lecture shows how to find the inverse of discrete Fourier transform. In other words, the equivalence signal in frequency domain is given and you want to find the sequence in time domain. So you are going to say that xk is given and we need to find the sequence x of n. That's the inverse of discrete Fourier transform. And this formula given above is going to be used to find the inverse. Observe the following. There is similarity between how to get the xk from xn. The difference here, first you are dividing 1 over n. It was not there. And instead of summing these variables from n equals 0 to n minus 1, no, you are using now from k. And instead of using a to the power minus j, it's a power plus j. That's another difference. And of course, when you find the expression, it will be function of n, and then you start substitute n is equal 0, 1, 2, up to n minus 1. So let's go ahead and use a simple example to show how to find the inverse of discrete Fourier transform. The example in our hand here is very simple. Let's say that xk is given as 0, j, 0, minus j. So that will be x0, x1, x2, x3, and we're going to use substitute in this expression. So we'll write it has to be x small. So xn, the sequence, equal to 1 over n. N here is equal to 4. Same thing. That's n minus 1. So 1 over 4. And sigma, instead of n, would be from k equals 0 to n minus 1, which is equal to 3. The expression say here, x of k, all right, and you have e to the power of j, 2 pi n k divided by n. Again, we'll substitute n equal 4. 2 cancel with 4 will be equal 2, so just make it 2 on the bottom here. So that's the general expression. Now, we'll start substitute by the value of k. So you have 1 over 4, put k equals 0, you have x0, and e power 0 is equal 1, plus kx1, and put here k equal 1, so be e to the j pi n over 2, plus x2 e to the power j in pi, plus x3 e to the power j 3 in pi over 2. Excuse me. Now I start to find the value of x0, 1, 2, 3, and substitute. So I have 0, j minus j. So that will be 0, and that would be 0. So what's left? J and minus j. That's equal to plus j, and that's equal to minus j. So let me write it down here. X of n is equal to 1/4, and I have x1 is equal to j to the power of e j pi n over 2, plus that's 0, so I have x3 is equal minus j. All right, that's minus j times e to the power j 3 in pi over 2. So that's the expression for x of n. Now you start substitute from n equals 0, 1, 2, 3, and so on. So let's see, the value when n equals 0. So x of 0 is equal 1/4 j e to the power of j0 minus j e to the power of j0. It will be equal to 1/4 j e to the power of 0 equal 1 minus j, so it's equal 0. So that's the first value. n equals 0. Let me get n equal 1. So it will be x when equal 1. I substitute by the value of 1. J e to the power of j n equal 1, so pi over 2. The second value minus j e to the power of j 3 pi over 2. Now that's j e to the power of j over 2, it's cosine pi over 2 plus j sine pi over 2 minus j. You have 3 pi over 2, so you have cosine 3 pi over 2 plus j sine 3 pi over 2. When you do that, you have j. Here, cosine pi over 2 is equal 0, and that's equal 1, so it will be j minus j. Cosine 3 pi over 2 is equal 0, and that will be equal to minus 1, so it will be minus j. So when we do that, j times j is equal minus 1, minus and minus plus, and j is minus 1, so it will be equal to minus 2. Remember that we have 1/4 here. We didn't write it there, so that's 1/4 and 1/4, 1/4. So divided by 4, so it's equal minus 1/2. So that's the value of x at n equal 1. If you continue, I did that already. So when n equal 2, it will be equal 0. And when n equal 3, x will be equal 1/2. So that will be the value of each x. So if you sketch it with respect to n, and that's x of n, the sequence, the value here is equal 0, and at 1, it's equal 0.5, minus 0.5, I'm sorry, minus 0.5, and 0 at 2, and 3, it's equal 0.5. So that's the sequence, the inverse. Again, I got this simple example just to know how to apply the formula. It's very simple. If you have a complicated one, it's very simple. You can use MATLAB. You remember last time we said to find the discrete Fourier transform, use the function IDFT. Same thing. If you want to find the inverse, just use IDFT. And do that. Come to the command line and write your capital X that was given in this problem. It was given to 0, I, 0, minus I, semicolon. Then you go second command, you write X. You can write XK if you like. Doesn't matter actually. Just you have to be different, that's all. Make it this one X capital and this X small. MATLAB distinction between both. It's equal to inverse fast Fourier transform, and then your big X. Don't put semicolon here with the result. Then you get the result. You just get the result exactly as you did here. And this is another way to check your answer for finding the inverse. I think maybe in the beginning you think that the formula is complicated, but now it's very simple, and even you have help from MATLAB. All right. Thank you for your attention.